Alright guys, so I forgot to do last time's video, but this time I swear I'll get it. So just as a recap, if you didn't get my Wakelet, last week we did an ed puzzle over photosynthesis and respiration. We did notes, a Kahoot, and optional there were 2 games that you could play. It wasn't required, it was just for your fun kind of thing. And then you had a review of the comparison of photosynthesis and respiration, and then also another review. We did a cell energy test. Make sure to get that done. Also, you have two chances to get a good grade, so make sure you use that. And then this week we have a couple of things. We have a warm-up, and then we have an ed puzzle. And then we'll do some notes and a bubble lab demo. Wednesday we have a warm-up, an egg demo, cell transport notes, drill 1 and drill 2, those are quizzes. And then on Friday and Monday we have a warm-up, a drill 3, which is a quiz, a transport demo, cell transport practice, it's a daily grade, so make sure you do that. And then a cell transport quiz. That quiz, you get unlimited attempts, and if you make 100, you can drop your lowest daily grade. So I highly recommend you doing that. So we're going to go to my Canvas page, and then this link right here is to the current test, so make sure you get that done. And then this is the current module assignment. Click on that. Sorry about that. Everything got published and I didn't mean for it to get published. So you have a warm-up. On the warm-up you have a few questions. You'll watch the video, answer the question that goes with it. There should be, 11 questions. So make sure you get that done. And then we have an ed puzzle. So you'll watch the video and answer the questions. Where these little dots are, that's where questions are at. And then you have notes. Cell membrane notes. There's a video clip after this ad.
As we reopen, don't you want your pocket of America to still feel like its own?
Every living thing is made up of cells. Your skin, blood, heart, every tissue and organ in your body begins its existence as a single cell that divides and divides again. The membrane of the cell is a bumpy film of fatty molecules. Proteins rise like trees from this oily layer to pump and channel minerals and nutrients through the membrane. Other proteins use their branches to trap hormones that activate the cell. Some hormones are small enough to slip through the membrane to instruct the cell to move, grow, divide, or even die. Larger hormones dock at the protein receptors. The receptors send messenger molecules to the enzymes and organelles crowding the cell. Some messages reach a network of tubes called the endoplasmic reticulum. Channels within the tubes then release calcium, triggering cell activity. Together, messenger molecules and calcium command microfilaments to contract or relax. They may also tell the cell membrane to recycle its components. Tiny honeycombs of proteins swallow up pieces of membrane along with hormones and their receptors. After ingesting its host, the protein structure falls apart, liberating a balloon-like vesicle into the traffic of the cell. The protein building blocks are then ready for a new round of ingestion.
Alright, so there was that video clip. So the first thing is cell membrane structure and function. Basically, it is the living boundary of all cells, so it's going to be what contains it and makes sure it has strength in keeping its shape. It regulates what goes in and out, so these protein channels will act as like a kind of like a highway system, if you want to say, and it allows different molecules to go in and out of the cell membrane. It's composed of a phospholipid bilayer, so bi meaning two. So it has two layers of the phospholipids, and these proteins are going to be embedded in the phospholipid bilayer. No, that's not going to work. So the cell membrane structure and function. So the cell membrane, again, it's in the outer living boundary. It gives it shape and strength, and it will allow things in and out of the cell, and it's made of this phospholipid bilayer. So take a minute, describe what the phospholipid bilayer means. So the fluid Mosaic model, it's going to be where the cell membrane can be often referred to as it. It gives its name because the membrane moves and flows between extracellular and intracellular fluids, allowing things to pass through it. So extracellular being the outside, intracellular being the inside, and things are able to flow through it. Membrane bilayer. So there's polar and nonpolar regions, and they have one head and two long tails. The head is polar, so it likes water. It's hydrophilic. It's attracted to water. So the fancy word for liking water is hydrophilic. Let's see. So another thing about the phospholipids, it has two tails, and the tails are nonpolar, so they're hydrophobic. They hate water. So the tails will push the water away, while the head is waterphilic. It loves water. So you're going to draw this off to the side: polar head, nonpolar tail, likes water, hates water. So which biomolecule do you think the tails are made out of that makes them hydrophobic? So think of, what do we have that, like in food-wise, that hates water itself? So if you put a drop of oil in water, does it mix with it or does it not mix with it? So the reason the membranes is two layers and not just one is because the water on the outside and on the inside of the cell. So the heads can touch the water while the tails can't, therefore two layers of phospholipids come together so that the tails can turn inward away from the water. So remember, hydrophilic heads, hydrophobic tails. So polar versus nonpolar. So polar means that both positive and negative poles, so that the substances have both. Nonpolar means that the substance has a balance of positive or negative. Polar things like polar things, water is polar. Nonpolar things like other nonpolar things, which an example is oil. Oil is nonpolar. That's why oil and water do not mix. So we see the lipids are on the inside of the bilayer. How can this keep my cell from taking in too much water in a short period of time? So think about that. Cell membrane proteins. So the proteins can fit in the membrane because they have a polar region and a nonpolar region. Nonpolar regions anchor it in the membrane, and the polar regions sit outside the membrane. The marker proteins the proteins that can identify what's going in and out, they're called marker proteins, and they decide what goes in and out. Let's see if this video clip works. Nope. Channel proteins allows the passage of a specific molecule going in and out of the cell membrane, and it's built as like a channel. Receptor proteins, they have a specific shape and only allow certain molecules to bind it and enter the cell. Kind of looks like a turkey. Cell membrane proteins have carbohydrate chains attached to them. These proteins can act either as markers for recognition or receptors for communication. And so we have a protein here, a protein channel here, and so we are consistent of different proteins in the phospholipid bilayer, and those act as like channels, or they allow certain molecules in based on that protein channel. We have hydrophilic polar heads and hydrophobic tails, so it's a lipid bilayer. It's 2 layers in one. If you have any questions, feel free to contact me. Oh, I forgot to show you the best part. So I'm going to do a bubble lab, and this is where I'm basing off my information for the bubble lab, so let's play it.
This representation is a way to understand the different cell membrane properties that can be illustrated by using bubbles. Cell concept 1. Membranes are fluid and flexible. Notice how the bubble film is able to bounce up and down without breaking. This is similar to the cell membrane. Now, notice how the light reflects on the bubble film. This demonstrates how the molecules move on the cell membrane. Concept 1 was able to show us how membranes are fluid and flexible. They are not static and change to be able to adapt to changing conditions that the cell membrane undergoes. Cell concept 2. Membranes can self-repair. As you can see, even with the whole hand going into the film never breaks, and when the hand is taken out of the film, it is able to go back to the same shape it was before. This is similar to the cell membrane because it is able to repair after there is breaks in the phospholipid bilayer. Concept 2 was able to show us that the lipid bilayer can be fixed by the attraction of the phospholipids in the cell membrane. Cell concept 3. Eukaryotic cells feature membrane-bound organelles. As a smaller bubble is formed inside a bigger bubble, this shows that layers are created due to a creation of a separate air compartment. In conclusion, we are able to see that in a eukaryotic cell, the membrane also has a phospholipid bilayer, and they have membrane-bound organelles that create compartments within the cell. The primary structure of the outer cell membrane, as well as the membranes that enclose organelles, is a double layer of phospholipids known as the phospholipid bilayer. Cell concept 4. Membrane proteins perform special functions. This idea consists of a formation and existence of specialized proteins which are embedded within the lipid bilayer, which gives the membrane unique properties. One example of these proteins are channel proteins. These proteins form a passageway for larger or electrically charged molecules to pass through the membrane. Just like the pencil made the
if you look up the video, you can find it.